Okay, this video explains how to use percent composition to find an empirical formula. If you remember from class, an empirical formula is basically the lowest whole number ratio of a compound's formula. We're going to take the percents that are on the paper and we're going to pretend like they are percentages of 100 grams of our substance. Because if I have 100 grams, the whole idea is that 94.1% of 100 would be 94.1 grams. And 5.9% of 100 would be 5.9 grams. If I can convert these to grams, then I can convert grams to moles. And if I do that, I can use the moles as the subscripts that go in my chemical formula. So what we're going to do is we are going to take 94.1% and I'm going to write it down as grams. Instead of percent oxygen, it's grams of oxygen. And I'm going to take grams of oxygen on the bottom, moles of O on top. I know that in 1 mole of oxygen there are 16.0 grams based on using the periodic table to find that mass. If I do that, I will come up with 5.9 as my number of moles. I'm not going to write the word moles there, I'm just going to leave it. And 5.9% hydrogen will become 5.9 grams of hydrogen. Convert that to moles. Grams of hydrogen goes on the bottom, moles of hydrogen goes on top. The periodic table has a mass of 1.0 for hydrogen, so there's going to end up being 5.9 moles of hydrogen. So what I'm proposing to you is that these two numbers would be my subscript. But if you look at it, H is going to be written before the O in the compound. It doesn't make sense to have H 5.9 O 5.9. I can go ahead and round up and look at it as H6O6, but I just told you that the empirical formula is the lowest whole number ratio. I can either reduce that right now. Both of those are divisible by 6, which makes that HO. Or an alternate way to do this is to work with the numbers before they ever get into the formula. I'll show you this with my next problem, but often what I do is divide both numbers while they're still over here. But my final answer here for the empirical formula is HO. Here's my second example. A compound is 29.1% sodium, 40.5% sulfur, and 30.4% oxygen. We're going to find the empirical formula. So we're going to assume again that these are the numbers of grams. So I've got 29.1 grams of Na. I'm going to convert that to moles of Na. In 1 mole of sodium, there are 23.0 grams. Well, that comes out to be 1.3 moles. I'm going to do the same thing with sulfur. 40.5 grams of sulfur from the percentage. In 1 mole of sulfur, there's 32.1 grams. If I do the math in my calculator, I'll again get 1.3. Then I've got the 30.4% of oxygen, which will become grams. In 1 mole of oxygen, there are 16 grams of oxygen. And if I do that, that comes out to be 1.9. Well, unlike the last time, if I put these into a formula to kind of start thinking about it, they're not close to 1. These are closer to 1, but the 1.9 is closer to 2. Like, I can't just simply round them up or round them down. Like, there's not an easy solution. So here's what I recommend. I recommend taking each number and dividing it by the lowest. Well, the lowest number out of 1.3 and 1.9 is 1.3. So these divided by themselves come out to be 1. 1.9 divided by 1.3 is 1.5. Okay, so I can go back in and put these in. I'm going to write the ones for now. That looks somewhat better, except I cannot have half of an oxygen atom. I have to get rid of the half. So there will be times where you will have to multiply by something in order to make these numbers equal a whole number. Well, how you get rid of a half is you multiply by 2. So I'm going to multiply the whole thing by 2. NA, if it's 1, will become NA2. S1 will become S2. And O1 and a half will become O3. That is my lowest whole number ratio, and that is my empirical formula. Now, sometimes you can be asked to take the empirical formula and calculate the molecular formula. So with my examples that I have so far, if I have something like the formula of this C3H3O2, and I'm told that that is an empirical formula, then I want to find the molecular formula if it has a mass of, let's see, 142 grams. Well, how we do that is we compare the masses. The molecular formula is just a multiple of the empirical formula. So if I calculate the mass of this, I'll see that the empirical formula mass is 71 grams. If it has a mass of 71 grams, 142 is double that. So what that means I need to do is double everything in my formula. So I need to make the C3 become C6, I need to make the H3 become H6, and I need to make the O2 become O4. So there's some things that I can do with percent composition and with empirical and molecular formulas.